Well, if you've ever wondered what's inside of an Eaton twin and countershaft transmission, this is it. This is all the gears, it's all there is inside of an Eaton twin countershaft transmission. The upper countershaft is right here on this side. The lower countershaft is right down there on that side. This is the main shaft. The main shaft is not part of the input shaft, but the front of the main shaft does slide into a pocket bearing at the end of the input shaft. I have a main shaft out of a similar transmission. It's just a long, straight shaft with a series, slippery shaft with a series of splines on it. The machined shoulder at the end fits into the pocket bearing on the input shaft. Particular to these main shafts, you'll find a stop here at the end. In this case, it's a little blob of weld because it broke. Normally there's a small roll pin associated with that. That's part of the mechanism that puts all the gears, that constructs the gears onto this main shaft. The main shaft fits inside the transmission, somewhere along the lines of that, but all these gears, don't drop that. All of these gears are floating on it. They're mounted on it, but they're not attached to it. I can turn the gears, maybe, and the main shaft doesn't turn. You can see the sliding collars spline to the main shaft, and when I turn the gears, the countershafts turn, the input shaft turns, but the main shaft doesn't turn. Okay, so this is my input drive gear. This is splined to the input shaft, but this is two separate pieces. Immediately behind that is my fourth driven gear. Immediately behind that is my third driven gear. There's my sliding clutch. That's my 2-3 sliding collar. There's second gear, second driven gear, first driven gear, and I have another sliding collar here. That's my first and reverse sliding collar. Now, when I take this sliding collar and slide it this way, I'm going to lock this gear to the main shaft. The main shaft is going to turn, likewise. And when I take this one and slide it forwards, I'm going to lock the input drive gear to the main shaft, and I'm going to have a 1-to-1 ratio. Torque will flow straight through this transmission, all the way out into the auxiliary drive gear. The auxiliary drive gear technically is part of the main shaft, which is part of the front box, but the auxiliary drive gear is actually located in the auxiliary section of the transmission. This is the auxiliary section of the transmission. This gear is splined to the end of the main shaft, much like these sliding collars are. Anytime the main shaft is turning, the auxiliary drive gear is turning. The auxiliary drive gear meshes with the auxiliary countershaft here and the other auxiliary countershaft way down there. Let's see if I can get a light on that for you so you can see it a little better. There we go. There's my other auxiliary countershaft. So, auxiliary drive gear splined to the main shaft supplies power, torque, to the auxiliary section of the transmission. Immediately behind the auxiliary drive gear is my high and low range synchronizing collar. It's my sliding clutch. can see the shift fork there, and you can see the brass blocker ring there that synchronizes the shift on the cone-shaped surface on the auxiliary drive gear. Right now, it looks like I'm in low range. It looks like that sliding collar has been pulled backwards towards the end of the transmission case. Deep down inside that transmission case, right there at the end. See that gear right there? It's got the two pink teeth. Those aren't girl teeth, those are timing marks. I'll talk about timing this here pretty quick. That is the output drive gear. That is splined to the output shaft. The output shaft also runs through the middle of that sliding collar right there. I don't know if you can see the output shaft. I think it's buried down in there. Somewhere down inside of them workings down in there, you'll find an output shaft. The other end of the output shaft is connected to that piece. That's my output drive yoke. Just inside the output drive yoke, you'll find a housing that mounts the output drive yoke, or output drive shaft, excuse me, on a pair of tapered roller bearings. We're going to have a lot of conversations about tapered roller bearings, but there's two tapered roller bearings inside that housing right there, that black and red housing. That supports the output shaft in the transmission case. The output shaft is mounted firm. It's not allowed to move in or out. Of course, the output yoke is splined to the output shaft, and there's a big hairy nut there that holds everything on. Back inside the transmission, like I said before, that's my auxiliary drive gear that delivers torque to the rear section of the transmission. The auxiliary drive gear makes the auxiliary countershafts rotate. Go in there. The upper auxiliary countershaft right there. And they're meshed. They're connected. You can kind of see they're meshed in there. So if the auxiliary drive gear turns, both of those auxiliary countershafts are going to turn. Like this. Ooh, it's not turning. Why is it not turning? Because none of my sliding collars are engaged. Let's see what it would look like if we could engage one of those sliding collars. Sometimes it's easier said than done. Sometimes sliding collars engage real easy. Sometimes we need some help from a lever. There we go. Now we're engaged. Now I have a gear. In this case, it's my first driven gear, locked to the main shaft through that sliding collar. You all know how that works. Makes the main gear spin, makes the auxiliary drive gear turn. If the auxiliary drive gear is turning, the countershafts are turning. The auxiliary countershafts are turning. So right now, as the auxiliary drive gear turns, the auxiliary countershafts turn. Down in there, at the other end of the countershaft, the other gear on that countershaft. This countershaft is just like the countershaft in the main case. Both of these gears, the small one in the back and the big one in the front, are mounted to the same shaft. They both rotate at the same speed. This is a direct drive. So it's a one-to-one piece. And you can see engaged with that is the output drive gear. The output drive gear floats on the output shaft. It's not connected, it's not splined, it's not hooked to anything. It's just kind of mounted on the shaft. It sits there until that sliding collar in that synchronizer slides over and locks it to the output shaft. As it is now, the sliding collar does look like it's engaged with the output drive gear. So torque would be flowing from the auxiliary drive gear through the auxiliary countershafts into the output drive gear, and then out the end of the transmission. It would look like this. If it was turning, it would look like that. Oh, don't grind up my light. There we go. You can see that's turning. See the output shaft is turning. And life is good. I'm in low range. This transmission has been taken apart a few times. I have my students take this apart a few times. And sometimes they don't put it all the way back together again. On the upper left-hand side, upper right-hand side of the transmission, excuse me, it's the upper right-hand side of the back box, you'll find the range cylinder. The range cylinder has two air hoses connected to it. It's supposed to have two air hoses connected to it. This one just has two holes in it where the air hoses used to go. If I put air into this hole, I'm going to pressurize this end of the cylinder, which is going to cause the piston to move forwards. If the piston moves forwards, that sliding collar is going to move forwards, and it's going to engage in the back of the auxiliary drive gear. If I put air into this hole, I'm going to pressurize this side of the slave cylinder. The piston is going to travel outwards towards the rear of the transmission. That's going to cause that shift yoke to move backwards towards the rear transmission and lock the output drive gear to the output shaft, causing the second reduction. Those two countershafts are a reduction. That's an underdrive gear ratio. It looks harder than what it is. Let's see what happens if I put air into the high range side and pressurize that cylinder. There it is. That's it. That sliding collar came forward, and that is now engaged with the clutching teeth on the auxiliary drive gear. Because I'm still in gear, I'm still engaged in first gear, but I'm not in low range anymore. I'm not in low range because my output drive gear is no longer connected. What I've done now is hooked the output shaft directly to the main shaft, and I get a 1-to-1 ratio. You can see how much faster that yoke is turning now that I'm in direct drive. Wait, you want me to put it back in low range? Alright, let's put it back in low range. I knew you guys were going to ask me to do that. Put it back in low range. I'm going to put air pressure in that side. We're going to force the piston to pull that yoke bar out, away from the transmission. Let's see if it works. It does. Did. Remember now, it only takes 60 pounds to do this. The air pressure regulator on the side of the transmission depressurizes the air to 60 pounds. It's still in gear, still engaged in first gear. Now, look how much slower that output yoke is turning. That's my low range. The yoke bar is pulled out towards the rear of the transmission. Back in high range. Alright, this is the last time. High range. It's not first gear now, it's sixth gear. There it is. Look how much faster that turns. This is actually a 9-speed transmission. It's hard to tell a 9-speed transmission from a 10-speed transmission because they look so much the same. But the operation is the same. 8 speeds, 9 speeds, 13 speeds. The range cylinders in all of these transmissions work the same way. Hope this helps clears it up. I hope it doesn't make any more questions, but if it does make some questions, let's bring them to the surface. Let's ask and we'll find out. We'll get an answer to your questions, all right? Thanks for playing.